Hi, this is section 5.6, additional trigonometric graphs. So in this section, we'll be looking at the graphs of tangent, cotangent, secant, and cosecant. So let's begin. So they start us off with the period. This time the period is pi over absolute value of b, not 2 pi this time. And there's a phase shift as well, negative c over b, that's the same formula. And this time the vertical asymptotes are at negative pi over 2 and positive pi over 2. So our inequality is not going to go from 0 to 2 pi for these graphs. For tangent, the inequality, the endpoints are negative pi over 2 and positive pi over 2. So that's an important distinction. And for cotangent, the period is the same as tangent, and the phase shift is the same as well. And the inequality is a little different. The asymptotes are at 0 and pi. So another key distinction, so careful when you're doing tangent or cotangent to make note of the endpoints for the inequality. All right, so let's do our first example, which is tangent. All right, let's find the, let's just go straight into the period first. The period is pi over absolute value of b, which is pi. So remember, this is your A, your B, your C. Pi over 1 is just pi. And then our phase shift is negative c over b, which is going to be negative pi over 2 divided by 1, which is negative pi over 2. All right, so let's do our inequality. Remember the endpoints for tangent are negative pi over 2. X, the argument goes in between, and positive pi over 2. So let's solve for x by subtracting pi over 2. And we should get negative pi less than x less than 0. All right, so that's great. So now we have our two asymptotes. Our first asymptote is at negative pi, and our second asymptote is at 0. So let's call this negative pi. So that's going to be our first asymptote. And the other one is at 0, which is right on the y-axis. And we need three midpoints. 1, which is negative pi over 2, 2, negative pi over 4, and 3, remember, you add these, divide by 2, you're going to get negative 3/4 pi if you do that. And for tangent, the midpoint is always going to be 0. And then, if you recall, tangents look like this. So the A tells you, sort of like an amplitude, but not really. If 1 is here, then 1/3 would be about right here somewhere. And then if negative 1 is down here, then negative 1/3 would be approximately right there. So our graph would be here and here. So if you connect those points, you're going to get your tangent graph. If this would have been a negative 1/3, then you would have put the points here and here, which would have turned the graph into this direction. Would have looked like a cotangent graph. All right, let's take a look at a cotangent graph. So start off the same way. A is 1, B is 2, C is negative pi over 2. So the period is pi over B, which is pi over 2 is our period. All right, our phase shift is going to be negative c, which is actually positive pi over 2, because c is negative. So the negative of a negative is a positive, divided by b is going to be pi over 4. That's our phase shift. All right, so let's do our inequality. So this time, remember, for cotangent, the endpoints are 0. Argument goes in between. And the other endpoint, or the asymptote, is going to be pi. So if you add pi over 2 to both sides, you're going to get pi over 2 less than 2x less than, that's going to be 2 over 2 plus 1 is 3 over 2 pi. Divide by 2, which is the same thing as multiplying by half. And you're going to end up with pi over 4 less than x less than 3/4 pi. All right, so now we know our asymptotes are at pi over 4. We'll call that pi over 4. and 3/4 pi, we'll call that 3/4 pi. Two asymptotes. All right, midpoint. Add these two numbers, divide by 2. You're going to get pi over 2. All right, and then we need another midpoint between these two. So let's see, the midpoint between those two, let's actually find that out. So what's pi 4th plus pi 2? Well, LCD is 4. You get 3/4 pi times a half. It's going to be 3/8 pi. All right, and then the last one, if you add these two and divide by 2, let's see, times 2 times 2, you're going to get 2 plus 3 is 5/8, because you're going to multiply by a half. All right, so the midpoint is your 0. Remember, cotangent looks like this. So the A is 1, so that means you're going to go up to 1 and down to -1. At this point, you're going to go up to 1, and at this point, you're going to go down 1. So it's going to look like 1 here, -1 there, and you get infinitely close to the asymptotes just like that. Same thing, if this would have been a -1 for A, then it would have looked like a tangent graph. All right, secant. So in order to graph secant, you first have to graph y equals the reciprocal, which is cosine. So let's graph cosine first. So we'll start off with the inequality has to be between 0 and 2 pi. Argument goes in the middle. Solve for x. So this is the same thing as 8 over 4. It's the same thing as 2. And so you're going to get 8 plus 3 is 11/4 pi. All right, so now we have our starting point, which is 3/4 pi. End point, 11/4 pi. So this is our start and our end. All right, now we need midpoints. So add those, divide by 2. So 11 plus 3 is 14. So that's going to be 7/4. Now we need this one. Well, the midpoint between 3 and 7 is 5. So that's got to be 5/4 pi. And similarly, the midpoint between 7 and 11 is going to be 9. So 9/4 pi. All right, remember for cosine, we start at the amplitude. The amplitude is 1. So you're going to go up to 1 and down to -1. Cosine starts at 1. If you look at the unit circle, cosine starts at 1, 0, -1, 0, back to 1. So we're going to start at 1. Then we're going to go to 0, -1, 0, back to 1. And we're going to actually dash it because this is not part of the secant graph. It's part of the cosine graph. Then we're going to draw our asymptotes at the x-intercepts. That's where the graph is undefined. And lastly, we're going to draw our secant curves. And so that's how you would graph a secant function. All right. The last one is cosecant. So similarly, we're going to first graph the reciprocal, which is sine. All right, so we started off the same way. We use the endpoints 0 and 2 pi. The argument goes in the middle. We solve for x. Add pi. Divide by 2. And our final inequality will be pi over 2 less than or equal to x less than or equal to 3/2 pi. All right, so our starting point is 1/2 pi. Our endpoint is 3/2 pi. And then we got to find our midpoint. So our first midpoint is going to be 4. If you add these, you're going to get 4 over 2, which is 2. And then divide by 2, you get pi. Our midpoint between that is 3/4 pi. All right. And this one's going to be 5/4 pi. All right. If you didn't know that, you would add them, multiply by 1/2. That's how you get 5/4. Okay, so sine starts at 0. 0, 1, 0, -1, back to 0. So for the first angle, we're going to start at 0. And our amplitude is a half, so that's 1, then this is a half. That's -1, this has to be -1/2. So sine starts at 0. Then it goes, notice that it's negative. A is negative. That means we're going to go down first instead of up first. So that's the difference. If it's negative, you go down first, and then back to 0, then back up, and then back to 0. So there is your, whoops, I forgot to dash it. This is a dashed graph because we're not graphing sine, we're graphing cosecant. Then we draw the vertical asymptote at the x-intercepts. And lastly, we draw our cosecant curves, 1, 2. And that is the final answer. That concludes this section.